Good morning, grade 10 students. This is my video tutorial for the third module for quarter 1 titled Arithmetic Means, the Nth Term, and the Sum of Arithmetic Sequence. So we are going to have three topics. Let us start with arithmetic means. So since arithmetic means has already been discussed in module 2, let us just deal it with an example. So example, if two arithmetic means AM stands for arithmetic mean are to be inserted between 3 and 12, what is the first arithmetic mean? So what is being asked is arithmetic means, and what are given are 3 and 12. So 3 and 12 are two numbers where to be inserted with two more numbers which we then call arithmetic means. This one is the first arithmetic mean, AM1, and this one is the second arithmetic mean, AM sub 2. So how are we going to find AM sub 1? Because what is being asked is what is the first arithmetic mean? We all know from this sequence, since this is an arithmetic sequence, this one should be the first term, A sub 1. If this is A sub 1, then 12 must be A sub 4, because that could be, that will be the fourth term if two more numbers are to be inserted between them. Thus, this implies that first arithmetic mean will become the second term, and the second arithmetic mean will become the third term. So we are going to deal much with the second term because that is what being asked on the problem. To find the second term of this sequence or the first arithmetic mean, we are going to go back with the formula of an arithmetic sequence. Again, the formula for an arithmetic sequence is A sub n is equal to A sub 1 plus the quantity of n minus 1 times d, wherein A sub 1 is the nth term. Nth term refers to any number of term. That could be the fifth term, where n is equal to 5. That could be the 10th term, where n is equal to 10. That could be the second term. That could be the third term. So, since our problem is to find the second term or the first arithmetic mean, then we are going to find for A sub 2. Before we proceed with A sub 2, we are going to discuss what is D. And we have also, perhaps this has already been discussed for the previous topic. D is the common difference for an arithmetic sequence. Okay. N stands for the number of sequence. In this case, on our problem, our n is 2. So let us proceed. We all know from the given, from our problem, that A sub 1 is equal to 3 and A sub 4 is equal to 12. But we don't know what is D. D is not given. So we are going to find first the value of D before we can proceed with the value of the second term. To find the value of D, we are going to use again the formula A sub n is equal to A sub 1 plus the quantity of n minus 1 times the common difference. A sub n, we have another given here that the fourth term, A sub 4, the fourth term is 12 and the first term is 3 plus And on the fourth term, since this is the fourth term, we are going to use n as 4. Minus 1 times the unknown d, common difference. So we are going to have 9 from 12 minus 3 equals 4 minus 1 times the common difference. Oops, sorry. Uh, am I right? Okay, correct. 4 minus 1 is 3 times the common difference. To find the value of d is to divide both sides by 3, which is the coefficient of d, to cancel them to become 1. So we have 9 divided by 3 is 3. Then the common difference is 3. Okay, we now have d as the common difference. We can now proceed with the main problem. This is just a preparatory. We have just looked for one unknown which is needed for our main problem. Our main problem is the second term. What is the value of the second term, or the same as the first arithmetic mean? Okay. Since based on our computation, the value of d is 3, we can now proceed with the second term. The second term should be, or the first arithmetic mean should be a sub 2 is equal to a sub 1 plus the quantity of 2, the second term, minus 1 times the common difference. Given a sub 1 is 3 plus 2 minus 1 times our computed value of d is 3. So we have 3 plus 1 times 3. That is a sub 2 is 6. Therefore, since a sub 2 is 6, then what is being asked, the first arithmetic mean, am sub 1 is equal to 6. The rest, am sub 2, you can just simply compute for that using the same formula. Next topic, our topic is the n term. N term is finding any term on an arithmetic sequence given any uh, at least two numbers on an arithmetic sequence. Okay, let us take an example. What is the seventh term of an arithmetic sequence where the fourth term is 10 and the eighth term is 18? So based on the problem, we have the given a sub 4 is equal to 10 and a sub 8 is equal to 18. What is being asked is a sub 7. If we just know what is the common difference, then we can simply find for a sub 7 by adding the common difference to 10 until we get a sub 7. But the problem is we don't know what is the common difference, and the givens are the fourth term and the eighth term. Okay, so first, we are going to find the common difference. To find the common difference, we are going back to the formula a sub n is equal to a sub 1 plus the quantity of n minus 1 times the common difference. This is our task, find the common difference. Okay, we know that the fourth term is 10 and we don't know the first term. Since we are dealing with the fourth term, we are going to have change n with 4 minus 1 times the common difference. So we have 10 is equal to a sub 1 plus 3d. Okay. This is leaving us with two variables. To find the data for two variables, we are going to have another more formula. Our first formula is that 10 is equal to a sub 1 plus 3d. Next, we also know that a sub 8 is equal to 18. So we are going to change a sub 8 with 18. Is equal to, again, a sub 1, that is unknown, plus the 8th term, change n with 8, minus 1, 1 times the common difference. So we have 18 is equal to a sub 1 plus 7d. Okay, that is our second equation. We can now simply find the common difference by using this first and second equation. So, how are we going to find the common difference? To find the common difference, we are going to cancel out a sub 1. To cancel that out, we are going to use find ano ba yun? Elimination method. So we have 10 on our first formula is equal. Next topic, our topic is the n term. N term is finding any term on an arithmetic sequence given any at least two numbers on an arithmetic sequence. Okay, let us take an example. What is the seventh term of an arithmetic sequence where the fourth term is 10 and the eighth term is 18? So based on the problem, we have the given a sub 4 is equal to 10 and a sub 8 is equal to 18. What is being asked is a sub 7. If we just know what is the common difference, then we can simply find for a sub 7 by adding the common difference to 10 until we get a sub 7. But the problem is we don't know what is the common difference, and the givens are the fourth term and the eighth term. Okay, so first, we are going to find the common difference. To find the common difference, we are going back to the formula a sub n is equal to a sub 1 plus the quantity of n minus 1 times the common difference. This is our task, find the common difference. Okay, we know that the fourth term is 10 and we don't know the first term. Since we are dealing with the fourth term, we are going to have change n with 4 minus 1 times the common difference. So we have 10 is equal to a sub 1 plus 3d. Okay. This is leaving us with two variables. To find the data for two variables, we are going to have another more formula. Our first formula is that 10 is equal to a sub 1 plus 3d. Next, we also know that a sub 8 is equal to 18. So we are going to change a sub 8 with 18. Is equal to, again, a sub 1, that is unknown, plus the 8th term, change n with 8, minus 1, 1 times the common difference. So we have 18 is equal to a sub 1 plus 7d. That is our second equation. Okay, let us continue. Uh, Next is we are going to find the value of d. How are we going to find the value of d is we still have a variable a sub 1. We cannot find the value of d if we don't have a value of a sub 1. Or we can perhaps use the elimination method. Okay, how are we going to use the elimination method? So since we now have two equations, we can just use elimination methods in the two equations. We both have a sub 1 and we both have terms for d. Okay, so in equation 1, we have 10 is equal to a sub 1 plus 3d. In equation 2, we have 18 equals a sub 1 plus 7d. To find d, simply we are going to subtract. If we subtract a sub 1 with a sub 1, subtracting by itself will become 0. So we have 10 minus 18 is negative 8. A sub 1 minus a sub 1 is equal to 0, or simply we can just eliminate that. 3d minus 7d is negative 4d. So to find d, just divide both sides by negative 4. Therefore, d is equal to 2. We now have the value of the common difference, which is 2. Having this common difference 2, we can now find any term by adding 2 on the fourth term going to the seventh term. But let us stick to the formula. Therefore, by computation, the value of d, or the common difference, is 2. Next, if we now have the common difference 2, let us now write our newly found given, or rather information. The common difference is 2. What is lacking is a sub 1, because on our problem, the formula requires for the value of a sub 1. Okay, so to look for a sub 1, you can just use any of the two givens, the fourth term or the eighth term. Let us just use the fourth term. So the fourth term, a sub 4 is 10 is equal to a sub 1 plus, since this is the fourth term, we are going to change n with 4 minus 1 times our common difference based on our computation is 2. So we have 10 is equal to a sub 1 plus 3 times 2. That is 10 is equal to a sub 1 plus 6. To find a is to use sabi ng iba, i-transfer daw, but the main reason is to add the inverse of 6. So we are going to subtract 6. 10 minus 6 is equal to a sub 1 plus 6 minus 6. We are going to subtract 6 on both sides, so that 6 on the right side will become 0 or will cancel. So 10 minus 6, that is 4, and what is being left is only a sub 1. Therefore, the value of a sub 1 is 4. A sub 1, based on our computation again, is 4. Now, we are very much ready to find the answer for the real problem. What is being asked is the seventh term. So what is being asked is a sub 7 is equal to a sub 1 plus the seventh term is being asked 7 minus 1 times the common difference 2. Since a sub 1 has already been computed, the same as d, we're going to change a sub 1 with 4. Therefore, we have 4 plus 6 times 2. We have 4 plus 12 that is 16. Therefore, the seventh term is 16. Some problems is as easy as ABC, but some problems are a little bit harder, such as this problem. Anyway, madali lang naman ang n term of an arithmetic sequence. Okay, let us now proceed with the sum of an arithmetic sequence. For the sum of an arithmetic sequence, we are going to stick with the formula. Let me now give you the formula. The sum of an arithmetic sequence, the sum of the first n term of an arithmetic sequence, noted as S sub n, is equal to n over 2 times a sub 1, 2 a sub 1 plus n minus 1 times t. Okay, that is the formula for the sum of any n term of an arithmetic sequence. Okay, let us take an example from 1 to 10. Find the sum from 1 to 10. Sum of all positive integers from 1 to 10. So we have the sequence 1, 2, 3, 4, 5, 6, 7, 8, 9, and last is 10. So our a sub 1 is equal to 1. Our a sub 10, a sub 1, a sub 2, 3, 4, 5, 6, 7, 8, 9, 10. Our a sub 10, the 10th term, has also value of 10. So what is the sum of the first 10 integers? First positive, sum of all positive integers from 1 to 10. Okay, so by the formula, S sub n is equal to n over 2 times the quantity of 2a sub 1 plus n minus 1 times the common difference. Okay, n stands for the last term, so we have S sub 10 is equal to 10 over 2. 2 times a sub 1 is 1, plus n, which is 10, minus 1, times the common difference. The common difference is 1 times 1. Simplify everything, so we have 5 plus, rather times 2 plus 9 times 1. So we have 9 times 1 is 9 plus 2, that is 11. 5 times 11, we have 55. So that is the sum of the first 10 positive integers from 1 to 10. Okay, next example. On page 7 of your module, there is a problem there. It says the sum of odd integers from 1 to 25. So to find that, let us again write the sequence. So we have 1, 3, 5, 7, 9, 11, 13, 15, 17, 19, 21, 23, and last is 25. So how many terms were there? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So we have 13 terms. So n is 13. A sub 1 is 1. A sub 13 is 25, the 13th term. And the common difference is 2. Difference is found by subtracting two consecutive numbers in an arithmetic sequence. So we have 3 minus 1 is 2, 9 minus 7 is 2, 17 minus 15 is 2. So we can now find the sum of this sequence. So we have to find the sum, the first 13 terms. 13. So S sub 13 is equal to n over 2, 13 over 2 times the quantity of 2 times a sub 1, which is 1, plus n 13 minus 1 times the common difference is 2, close bracket. So 13 over 2 is 6.5 times 2 times 1 is 2, 13 minus 1 is 12 multiplied by 2, that is 6.5 times 2 times 12 is 24 plus 2 is 26. 26 times 6.5 S sub 13, 26 times 6.5. So we have 30, 0, 3, 10, 13, 36, 33 again, 12, 15. So we have 0, 9, 6, 1. The total is 169. Okay, the 13th term is 169 based on your module on page 8. S sub 13 is equal to 169. Please take a look at the subscript of the S, typographical error. That should not be S sub 10. That should be S sub 13. Okay, so that is how we find the sum of an arithmetic sequence. My challenge to you is to find the sum of the first 1,000 term, or rather find the first 1,000 odd number, positive odd number. If you find the answer, then excellent. Congratulations.